Binary, sometimes called a base to numeral system, uses only two digits, 0 and 1. Every binary digit is called a bit. Conversely, decimal, or base 10, is the system we commonly use daily, comprising digits 0 through 9. Converting between these systems isn't too complicated in Python, but understanding the concept helps to know what's going on behind the curtain. Now, let us explore a detailed Python tutorial for this conversion. Please remember the purpose is to convert any binary value to a decimal one. It's quite a useful skill to have during programming tasks, especially when handling file data, network protocols, or encryption algorithms where binary and decimal forms often appear. Python provides a variety of ways to achieve this conversion, whether it's a straightforward method or a slightly more complex one for tackling problems dealing with large binary numbers. Most of the time, you might get by with a direct method known as int. However, this guide will demonstrate a non-trivial way with string manipulation for a better grasp on each step of the process. First, let's recall how we use the int function in Python. Simply put, this built-in function can convert binary string into decimal by specifying the base as 2. It's like saying, convert this binary string to a decithing. So, if our binary string is 11,011, we can convert it to decimal using int. And poof, we get 27 as the result. Neat, right? However, the goal is to dive deeper into the process without using the int function for more comprehensive understanding. Let's start by defining a Python function, binario_to_decimal, and pass a binary string as the parameter to this function. Inside this function, we will implement the conversion logic. Python definite binario_to_decimal, decimal is equal to 0, base is equal to 1 for digit in reversed, decimal plus is equal to int is equal to return decimal. First, we initiate our decimal variable with 0. The base starts with 1 for the rightmost bit, which when multiplied becomes the last bit. As we move leftward, we continuously multiply the base by 2 and add it to the decimal result if the bit is 1. If it's 0, we simply skip adding. Let's call our function with a binary string 1101. Python binary_num is equal to 1101 print. This code will give us the decimal result, which is 13 in this case. If you've followed along with the logic above, it might seem less cryptic. Now let's enhance our code to handle negative binary numbers. We know that in to complement notation for negative numbers, we flip the bits and add 1, an effective way to handle negative numbers in binary. This means our conversion function should cater to this, so let's tweak our code. Python definite binario_to_decimal, if binario is equal to dash, binary_num is equal to binario negative is equal to true, else, binary_num is equal to binario negative is equal to false, base is equal to 1, decimal is equal to 0 for digit in reversed, decimal plus is equal to int is equal to 2 if negative, decimal is equal to decimal if decimal 0, decimal is equal to 10 ***, lay return decimal. For negative binary numbers, we start by removing the negative sign and determining it's a negative binary number. Then, for the to complement binary, we subtract 1 if the initial decimal digit is 1 and make it 0. Afterward, we find the highest bit, which has a significant impact, and subtract it from decimal. It's always beneficial to test our code comprehensively, so let's create a couple of tests. Python print, #outputs, 13 print, #outputs, -7 print, #outputs, -1. As you see, our function can handle multiple cases correctly. Besides this method, some alternative or specific cases might require additional adjustments to the basic conversion procedure. But for most coding or algorithm-related problems, the function above will do the trick wonderfully. Learning such conversion mechanisms will make you a flexible problem solver. As such, it's no small feat. To see more content like this, feel free to visit Neeraj and subscribe.